Okay, welcome back. We're going to look at graphs now of y equals to plus minus bracket x minus p bracket square plus q. And as what we're going to do, we're going to plot all these graphs and try to figure out something. Now, the thing about all these kinds of graph, you can have a few kinds of things, all kinds of solutions here. We're looking at all three cases of solutions. One is no distinct roots, distinct real roots. Okay, one distinct real roots, one real root, and the last case is two real roots. Okay, two distinct real roots as well. Okay, so first and foremost, let's plot this graph. And on the left of my screen, you can see that I've done it on Desmos. Okay, and we're gonna pay attention to only the turning point. Okay, the plus or minus just tells us whether is it like a smiley face graph or unhappy face graph. Okay, so the turning point here, it's simply in this case, I'm gonna write it here, -1, 5. Okay, let's look at the other one. Oh, this should be plus. Let's just change it to plus. Okay. Oh, sorry. Okay, so if it's x plus 4, let's look at the turning point. The coordinate of the turning point is -4, 0. Alright, now let's look at the second one over here. Okay, we have somewhere lower. Okay, but same thing, let's look at only its turning point. We have -8, -9. Beginning to see something. Next, we have this over here. Let me find out where's the graph. Oh, okay, the turning point is here. Okay, so it's a maximum point now. So this is 7, 1.5. Okay. Next we have this, which is somewhere here. Okay, as you can see, this is only one real root. 5/3 is just -1.667. So I will just write it as -5/3, 0. And the last one, which is pretty interesting, it has 0, -6. Okay, what does this graph have to do with, what is the turning point? Okay, we're gonna actually, can I derive the turning points just by looking at the equation? Yeah, I practically can, right? So the y coordinate, isn't it just simply here? Okay, can you see the y coordinate is just simply all the q, or the value of q, in fact, right? All of them are just the value of q. Now, what about the x coordinate? Isn't the x coordinate the negative? Isn't it just this, the negative of this, the negative of this? In this case, also the negative of this. Okay, wait, maybe I use a different color, then it'll be easier. Okay, isn't this just the negative of this? This and this, this and this. Okay, this and this, this and this. Right, it is just the negative of each other. So it's pretty much interesting that if you have this kind of equations, right, that you can derive from completing the square. Actually, this can be derived from completing the square. You can easily derive the turning point of the graph just by looking at the equation. But you will ask me, what about the second one? Imagine if I just added a +0 here, an invisible +0. Isn't this the y coordinate of the turning point? Okay, there as well. So I just add a +0. Isn't this just telling me the y coordinate, right? It doesn't change the value of the function, but I just know there's an invisible one. Okay, what about this one where the x coordinate is 0? Okay, if you look at this very carefully, okay, it is just simply negative bracket x plus 0 bracket square minus 6. And this is so amazing that we can do with equations like that. You can use completing the. This just tells us that it has an x coordinate of 0, the turning point I mean. So we can easily infer the value of p and q here, which is simply the turning points. So this is -1, this is 5, this is -4, this is 0, this is -8, and this is -9. Okay, let me just write down the general equation first. Okay, so this x plus x minus p square plus q. Okay, so we're just looking at p and q, right? So this is 7 and this is 1.5, and this is negative 5 over 3, this is 0, and this is 0, this is negative 6. So when we ever give you such equations, you don't have to go and plot the graph, do so many steps to find the turning point, or sometimes you can even just find the turning point just like that. And it's pretty interesting, pretty much a shortcut way to actually figure out turning points of quadratic equations. Of course, knowing this is minimum because there's no negative in front. This is also minimum. This is also minimum. Okay, the turning points are minimum points. The turning point here will be your maximum point. Okay, and the turning point here will be a minimum point, and the turning point here will be a maximum point. Okay, and their line of symmetry is just simply their x coordinates, right, of the turning point, right? So it's pretty simple. You can just x is equals to -1, x equals to -4, x equals to -8, x equals to 7. All these are just simply the line of symmetry that we derive from equations. So practically, I like this kind of equations. It's pretty straightforward, to use them. And from this activity and this activity here, we kind of realize that we can just infer p and q that easily. So what does that mean for a graph such as this with y if you just generalize it, right? X minus p bracket square plus q. Okay, for a graph like that, you will only know that the turning point here, okay, is simply the coordinate of the turning point is p comma q. Yeah, that's all. And the line of symmetry is just line of symmetry. Let me just draw the line of symmetry up. Hopefully it looks okay. Okay, so this is the line of symmetry. The line of symmetry is simply x equals to p, regardless of anything. So and that's all we have for this kind of functions in this form of x minus p bracket square plus q. That's all. Thank you.